Hello everyone. In this tutorial video I like to explain how inductors work in a circuit in general and not exact formulas, now that I've explained how electromagnets work. In particular, since we remember electromagnets work because the wrapping of a coil makes a stronger magnetic field than a straight wire, it should not be too surprising that the symbol for an inductor looks like this. Although this is the generic inductor symbol, and there's a special symbol for iron core inductors specifically, which is similar, except there are two bars next to the coil symbol. Or the more modern interpretation you will see is bars drawn through the coil symbol and not next to it, as a more realistic depiction of what the core actually looks like. When an electromagnet or inductor is placed in a circuit, the electric current produces a concentrated magnetic field, and the field flux represents the storage of current or kinetic energy of electricity. And as a general rule, the greater the current, the greater the magnetism induced. This means, similar to how capacitors try to maintain a constant voltage, inductors will try to maintain a constant current, because we remember from a previous video, they resist changes in their magnetism, which is called hysteresis. So, when a change of current is applied in an inductor, it will automatically induce a voltage counteracting it. And likewise, if you decrease the current through it, it will have a voltage drop in the normal direction and not in the opposite direction. In theory, an inductor left on its own will store energy indefinitely, or have a constant rate of current in its magnetic field. But in practice, this is only possible with superconducting wire, because essentially almost all real-world wires, magnetic or otherwise, will have some internal resistance built into them. And we know from previous tutorials a resistance causes a decrease in current. So just like there is a charge and discharge of batteries and capacitors, there is a charge and discharge of inductors where, when the current in an inductor increases, it is charging, and when the current in an inductor decreases, it is discharging because it is giving it away to the rest of the circuit. One last thing to note about inductors before we delve into specific details in the next video is that the older term for an inductor is called a choke because of how it filters or chokes out high frequencies in radio broadcasting and similar applications. But most people in the technical industry no longer use the term choke and use the word inductor instead. So I would advise you to do the same. Now that I've explained the general principles/theory behind how inductors work, I can explain an exact formula to predict the amount of inductance something has, similar to how I went over capacitors in general before delving into a formula for capacitance after. Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos, and follow me on either Facebook or Twitter for more content.